So in this video, I'll be going over linear combinations in linear algebra and determining if B is a linear combination of our constant values here of A1, A2, and A3. So first, when we're looking at linear combinations, we need to remember what a linear combination is. So for a linear combination, what we're going to have is we're going to have a variable of x, multiple variables. So first variable of x1 times our constant value of a1, or a scalar value of a1, plus a second variable x2 times our constant a2, and you can do this any number of times to get a variable x of n times our scalar constant of a of n is going to equal something at the end here, which we can call b. So we can kind of see this a lot. So it can be something like 2x plus 3y is going to equal something. So that's kind of like a linear combination. So we have a variable x times a constant value of a plus another variable x2 times a constant value of a2. So when it comes to linear algebra, we can also see this in the form of, or solve this linear combination in the form of a matrix A times our scalar of x is going to be equal to b. So first thing we can do is we can take our constants here and we can multiply them by our variables. So we have x1 times our constant, our a1 here, of -2, 1, 1, plus x2 times a2, it's going to be 7, 1, 0, plus x3 times a3, -3, 3, 2, and that's going to, we're going to see, does this equal question mark our b value of 2, 0, 1. So what we have here is what we're going to have is just a system of equations. So we'll have -2x1 plus 7x2 plus -3x3 equals 2, 1x1 plus 1x2 plus 3x3 equals 0, 1x1 plus 0x2 plus 2x3 equals 1. So we have our system here, and this might look a little familiar. So then what we do is we turn this into our matrix, our augmented matrix of -2, 7, -3 with our solution of 2, 1, 1, 3, solution 0, 1, 0, 2, 1. So here's our matrix A times our scalar, or our variables of x, and then this will be b. So then we have -2, 7, -3, 1, 1, 3, 1, 0, 2 times x1, x2, x3 equals 2, 0, 1. So that's kind of our form here. So now what we can do is we can solve for our variable x here and see, does it have a solution? If it has one solution, that means it is a linear combination. If there's no solution, it means there's not a linear combination. So what we'll do is we'll take our augmented matrix and we'll just turn it into our identity matrix of 1, 0, 0, 0, 1, 0, 0, 0, 1 to solve for this side right here. So I do have a video on row reduction if you need a little more help on that, but I'll go through this part pretty quick so that we can see our solution here. So first thing we're going to do is we're just going to switch our row 1 and our row 3. So row 1 switches with row 3. We have 1, 0, 2. Our row 2 stays the same. And we have -2, 7, -3, and 2. So we'll solve here. We'll solve for the 0 here and the 0 here at the same time. So row 2 is going to be equal to negative 1 times r1 plus r2 to get 0 here. And our row 3 is going to equal 2 times r1 plus r3. So our first row stays the same, so 1, 0, 2, and 1. Row 2 is equal to negative r1, negative 1 plus 1 is going to be 0. Negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 2 is negative 2, plus 3 is 1. And negative 1 times 1 is negative 1, plus 0, we're going to have negative 1. And for our third row, we're going to have 2 times 1 is 2, plus negative 2 is 0. 2 times 0 is 0, plus 7 is 7. 2 times 2 is 4, minus 3, we have 1, and 2 times 2 is 1, plus 2 is 4. So next we'll try to make this third row 7 gone. So we'll do, scroll down a little bit. R3 is going to be equal to negative 7 times R2 plus R3. So our first row stays the same, and our second row stays the same. And our third row will have 0 times negative 7, 0 plus 0, 0. We'll have 1 times negative 7 is negative 7, plus 7 is 0. We'll have 1 times negative 7 plus 1, we have negative 6. And finally, negative 7 times negative 1 is 7, plus 4, we'll have 11. And we'll bring this back up here. So we can have more space. Finally, we'll do, well, first we'll make this negative 6 a 1. So we'll just multiply row 3 by a scalar. To make this 1, we'll do times it by negative 1 over 6. And row 1 stays the same. And row 2 stays the same. So we have 0 times negative 1, 6 is 0. 0 times negative 1, 6 is 0. Negative 6 times negative 1, 6 is 1. And then we'll have negative 11 over 6 for our side over here. And finally, we'll take this one here and we'll multiply it out so we can get zeros in our first two rows. So row 1 is going to be equal to negative 2 times R3 plus R1. And row 2 is going to be equal to negative 1 R3 plus row 2. So our row 3 stays the same. And now we'll have to do a little bit of fraction math with this one right here, but so we'll have 0 here and 0 times, we'll do R2 first. So 0 times negative 1 is 0, 0. So this is going to be, 1. And then negative 1 times 1 is negative 1 plus 1. We'll have our 0. So then here we'll have our R3 value is negative 11.6 times negative 1 plus R2 is negative 1. So 11.6 plus negative 1 is going to be negative 6 over 6. So we'll have 5/6. Sorry, I did a little backwards here, starting with R2. But then we'll move on to R1. We'll have, obviously we'll have 1. This will be 0. We take negative 2 times 1, negative 2 plus 2, we'll have 0. And then for this one, we'll have fraction math over here. We'll do negative 11.6 times 2, or negative 2, plus our R1 value is 1. So we'll have 22 over 6 plus 6 over 6 is going to be 28 over 6. We can divide that by 2 to reduce it, and we'll get 14 over 3. So we have 14 thirds. So as you can see here, we did get our identity matrix of 1, 0, 0, this diagonal of 1. So that means that we do have a solution. So it is, yes, it is a linear combination. So we can answer yes for our question. And our x values are going to be equal to our solution over here is 14 thirds, 5 6, and negative 11 6. So x1 equals 14 thirds, x2 equals 5 6, and x3 is equal to negative 11 6. So please like and subscribe if you found this helpful, and let me know if there's anything else I can do for you. Thank you.